Today I'm going to be talking about the inverse of a function. This is chapter 6, section 6. And first off, we're going to learn how to write the inverse of a function. And to do that, you're going to solve for x, okay? So instead of writing f of x, to make this a little bit easier, I'm going to write it as y. So we're going to do y equals negative 2/3 x plus 1. And now we're going to move everything over. We're going to isolate our x. We're going to get x by itself. So you're going to subtract by 1. So 1 minus y minus 1 equals negative 2/3 x. And then we can multiply both sides by a negative 3/2. And we get a negative 3/2 y plus 3/2 equals x. So this right here is our inverse of our original function, okay? And this says find the inputs when the output is negative 3. Well, negative 3 is going to be our y value, so we're going to plug that in. Negative 3. So it's going to be 9/2 plus 3/2, 12/2, and we get 6. So we just plug in and simplify. Okay, so let's find it for our second one. So we're going to make this y equals 2x to the 4th minus 5. We're going to solve for x, so we're going to add the 5. Y plus 5 equals 2x to the 4th. We're going to divide by 2. So we have y plus 5 divided by 2 equals x to the 4th. Now to get x by itself, we're going to have to 4th root both sides. Don't forget, since it's an even root, we have to do plus or minus. So our inverse is going to be plus or minus the 4th root of y plus 5/2. That is our inverse of our original function. Then I'm going to plug in negative 3 into our inverse. We get 2/2, which gives us 1. So our solution is plus or minus 1 for that one. So that's how you write an inverse of a function. So now what we're going to do is we're going to use that and we're going to graph these inverses, okay? So the first thing is let's graph the original function, negative 2x plus 5. So we can use it using y-intercept form, slope-intercept form. So our intercept is a positive 5, and our slope is a negative 2/1. Don't forget that's our rise over our run. So we're going to go down 2/1. Do that a couple times. We're going to draw our function. Okay. Now what we're going to do is we are going to write the inverse of our function. So we're going to subtract 5. Y minus 5 equals a negative 2x. And then we're going to divide by a negative 2. So we get a negative 1/2 y plus 5/2 x equals x. Now for the sake of graphing, so we don't mess anything up, we're going to rewrite this as the f of x to the negative 1. That notation means that what we're about to write down is the inverse of f of x. And instead of writing a y right there, we're going to write an x so we can graph this properly. So now this is in slope-intercept form, and we are going to draw our inverse, graph it. So our y-intercept is 2.5, and then our slope is down 1/2. All right, and if you notice, inverses are reflected over the line y equals x. So I'm going to graph that really quickly. So you can double check if it's a reflection over y equals x, then this is the inverse. Okay, let's try another one. we have the f of x equals 4x squared, and we have a restricted domain of x is less than or equal to 0. So that means x can be 0 or x can be negative. So that's going to help us use our table of values. So let's write a table of values. Okay, so we can use 0. All right, and our x values have to be less than 0, so we're going to use, let's use -1 and -2. So we have 4, we have 0 for that, 4 for this, 16 for this. Okay, so let's graph that. We have 0, 0, -1, 4, -2, 16. It's way up there. And then we make our nice curve for that. All right? Now, if our x values have to be negative, our y values have to be negative for our inverse. So we're going to find our inverse first. So we have y equals 4x squared. We're going to divide by 4. We're going to square root both sides. So we have plus or minus the square root of y over 2 equals x. Okay, and now our inverse, we have to write in inverse function form. F of x to the -1 equals, now this is plus or minus, and since we had to have negative numbers, we have to have the negative portion of this one, that's x. So this is going to be a negative square root of x over 2, and you'll see how this works when we do a table of values. Now be careful when you plug in, because we don't have negative values for the x for this time, we have to have it for the y. We only can plug in positive values for x because we have a square root. So we're going to plug in positive numbers. So I'm going to try 0, I'm going to do 1, and I'm going to do 4. So I have a negative square root of 0 over 2, which is 0, a negative square root of 1 over 2, which is a -1/2, and a negative square root of 4 over 2, which is a -1. So you see now we have 0 is allowed, and we have negative values for y, so our domain is correct. So we're going to graph 0, 0, 1, -1/2, 4, and 1. And now we have our inverse. Let's graph our y equals x, because it is reflected, and inverse is reflected over that line. Okay, and we've got it, looks great. Let's try another one. This next one is f of x equals x minus 3 cubed. So let's use a table of values for those. So I'm going to choose 1, 2, 3, 4, and 5. And the reason that I chose these is because we have a cubed function, and we need to get a nice curve of an s. And you'll see why that we'll get the whole entire piece of that s when we graph this. You'll see why I chose those values in a second. It's a -8. 2 minus 3 cubed is a -1. 3 minus 3 cubed is a 0. 4 minus 3 cubed is a 1. 5 minus 3 cubed is an 8. So we're going to graph that. We have a 1, -8, 2, -1, 3, 0, 4, 1, 5, 8. And now you can see that I chose those numbers because I get a nice S curve for that. Now I'm going to find the inverse. So I have y equals x minus 3 cubed. I have to cube root both sides. I'm going to add my 3, and I get the cube root of y plus 3 equals x. Write it in function notation. Okay, and so now I'm going to use a table of values. And what I'm going to use for this one is a -8, -1, 0, 1, and 8. So that gives us a 1, gives us a 2, that gives us a 3, gives us a 4, that gives us a 5. And now we're going to graph it. -8, 1, -1, 2, 0, 3, 1, 4, 8, 5. And now we have our nice curve right there. And if we draw our line, that looks perfect. Okay? And now if you take a look at the table of values, if you notice, the first one, we have 1, -8. And then for our inverse, it got switched to -8, 1. So you can use this to your advantage because all the inverse does is switch the x and y values. So that can help you when you're graphing. All right. What we've got next is using the graph to determine whether inverse of f is a function. So we're trying to determine if the inverse of this graph is a function or not. So what we can use is a horizontal line test. So we're going to draw a horizontal line, and if it hits this line more than once, the inverse is not a function. And if you draw a horizontal line and it only hits it once, the inverse is a function. So it's a kind of a quick trick to figure out if the inverse is a function or not. All right, next, we can determine whether functions are inverses or not. If we plug in inverses into each other and they cancel out, then they're inverses. So what we're going to do is we're going to take the f of g of x and the g of f of x. And what this means is, for this first one, we're going to take the g of x and we're going to plug it into this x right here. Okay, so we're going to plug it into the f of x. So what we're going to get is the fifth root of 5x to the fifth minus 9 plus 9 all over 5, because we plugged it in right here, right there. So we plug that in, and now we can just simplify. So we now have the fifth root of 5x to the fifth over 5. Those 5's cancel. We get the fifth root of x to the fifth, and that cancels to just x. So let's do this other one, and we're going to do it in the opposite direction. We're going to take the f of x and plug it into that x. So what that's going to look like is 5 times, here, let's do this, 5 times the fifth root of x plus 9 over 5 to the fifth minus 9. Don't forget that minus 9 at the end. So now these two cancel out. So we get 5 times x plus 9 over 5 minus 9. Well, these 5's cancel. So we get x plus 9 minus 9, which equals x. So if both of them simplify to just x, then these are inverses. Okay? So those are inverses, so it checks out. So we show our work. They both simplify to x, so those are inverses. I have one more example for you. Same thing, determine whether these are inverses. So our first one, we're going to do the f of g of x. So we're going to take this and plug it right into there. So we're going to have 7, and then we have x plus 4 over 7 to the 3 halves to the 3 halves minus 4. So that's on our entire thing. Now, do not get trapped. These 3 halves do not cancel. We have to multiply them out. This is x plus 4 over 7. And 3 halves to a 3 halves is a 9/4 minus 4. Now, if we look at this, this can no longer be simplified. So these are not inverses.